All right, so what happens, or what can I do if my leading coefficient is not equal to 1? Can I still use the, just one second. This is taking a little long time. So can I still use the integral zero theorem? Yes, I can, but now with a twist to it. So let's look at this. So what I have here, we're trying to figure out what are the factors. We're trying to factor p of x equals 3x cubed plus 2x squared minus 7x plus 2. And as you can see here, the leading coefficient is not equal to 1. So we must first start by finding a value of b over a, where b over a is equal to 0. Now, what is b? What is it? B are the factors of the constant term. So if you look here, my constant term is 2, and b are the factors of the constant term. So what are the possible factors of 2? Possible factors of 2 are plus and minus 1, plus and minus 2. Easy. All right. Now, we're going to also have to find the factors of the leading coefficient. The factors of the leading coefficient, so A must be a factor of the leading coefficient. So in this case, the factors of the leading coefficient are plus or minus 1, plus or minus 3. Now, what we have to do, we have now to find b over a. So I have to take the value of b and divide it by a, divided by the values of a. So in this case, if I take the plus or minus 1 and divide it by plus or minus 1, I'm going to end up with plus or minus 1. And if I take the plus or minus 1 divided by plus or minus 3, I'm going to end up with plus or minus 1/3. Now I'm going to have to take the 2 and divide it by the plus or minus 1. So that's going to be plus or minus 2. And then plus or minus 2 divided by plus or minus 3, that's going to be 2 over 3. So these are the possible factors. Okay? Now, where do you start with the testing? I usually start with the testing the integers. Okay, I start testing integers that are not fractions. It's easy to find. So let's start with P1. So that's going to be 3, 1 cubed, plus 2, 1 squared, minus 7, times 1, plus 2. So that's going to be 3 plus 2 plus 2, so that's 7 minus 7, that's a 0. Here we go, we found it. We didn't have to do a lot of work. So P at 1 is equal to 0. Therefore, x minus 1 is a factor of P of x, right? So the exercise that we had to do here, we had to find the factors of the constant, the factors of the leading coefficient, and then divide them and then test these factors. Now, since I found that the factor is x minus 1, then I can do here synthetic division. And it's going to be 1 here, and then 3, 2, negative 7, and 2. 3 times 1 is 3, adding, so that's a 5. 5 times 1 is 5, add, that's a negative 2. Negative 2 times 1 is negative 2, add, that's a 0. So what I have here is I have x squared, x, and the number. So 3x cubed plus 2x squared minus 7x plus 2 is equal to x plus 1, or was it x minus 1? And then my quotient was 3x squared plus 5x minus 2. All right, now I have to still factor this. In order to factor this, because my leading coefficient is not equal to 1, I have to find two numbers that multiply to -6 and add to 5, and I have to do decomposition. So multiply to -6 and add to 5, what do we have? We have 6 and -1. All right, so let's do the decomposition. So I have x 3x squared plus 6x minus x minus 2. Then I'm going to common factor. So what I have here is 3x, and I'll be left with x plus 2. And if I factor a -1, I'll be left with x plus 2. So now you know that my factors are x minus 1, x plus 2, and 3x minus 1. And that's fully factored. There is nothing else I can do. I am done. All right. Let's try one more. All right. So factor p of x equals 2x cubed plus x squared minus 7x minus 6. So first thing, I need to find the factors of the value for b, which are the factors of -6. So that will be negative plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. You see now I have more values. Possible values for a are the factors of 2. So the factors of 2 are plus or minus 1, plus or minus 2. Now we're going to have to find the possible factors by dividing b over a. So that's going to be plus or minus 1, plus or minus a half, plus or minus 2, plus or minus, if I divide 2 by 2, that's going to give me 1, so I don't have to rewrite that, plus or minus 3, plus or minus 3 over 2, divide now 6, plus or minus 6, and then plus or minus 6 divided by 2, that's 3, so that's going to give me this. I don't have to rewrite that. You see, there's too many factors here. Start with the lowest. So let's try p negative. So that's going to be 2 times -1 cubed plus -1 squared minus 7 times -1 minus 6. So it's going to be -2 plus 1 plus 8 plus 7. I don't know why I'm doing that. Minus 6. So that's going to be 8 minus 8. That's going to be a 0. So that's a factor. Now, let's do synthetic division. So -1, 2, 1, -7, and -6. So that's 2 times -1, that's -2. I'm going to add, that's a -1. -1 times -1, that's a 1. I'm going to add, that's a -6. -6 times -1, that's 6. Add, that's a remainder of 0. So far what I have the following. 2x cubed plus x squared minus 7x minus 6 equals to x plus 1 times. So this is x squared, x, and the number. So 2x squared minus x minus 6. Now I'm looking to factor this. So I'm looking for two numbers that multiply to negative 12 and add to negative 1. So that would be negative 4 and 3. And I have to do decomposition. So I have x plus 1, 2x squared, minus 4x, plus 3x, minus 6. Common factor 2x, so that's going to be x minus 2. Common factor 3, that's going to be x minus 2. And that's going to be x plus 1, 2x plus 3, and then x minus 2. And then these are my factors. This is fully factored. All right, now let's see part 4. So we're looking at some application questions. So when f of x is equal to 2x cubed minus mx squared plus nx minus 2 is divided by x plus 1 plus 1, the remainder is negative 12. And x minus 2 is a factor. What does it mean that x minus 2 is a factor? That means f at 2 is going to equal to 0. Perfect. Now, and then x plus 1 is with a remainder of negative 12. That means f at negative 1 is going to give me negative 12. Now, what we have to do here, we have to determine what m and n is. So I need to use the information given, so I need to use this information, and I need to use this information to find m and n. Anytime there's two unknowns, there's two things that you're looking for, you need to have two equations. So let's use the given information. So I know that f at negative 1 is going to equal to negative 12 because we know the remainder here. So let's see what I plug in negative 1 in here. What do I get? So I get 2 times negative 1 cubed minus m times negative 1 squared plus n times negative 1 minus 2, and I know that's going to equal to negative 12. So that's going to give me negative 2 minus m minus n, take away 2 equals to negative 12. Negative 2 and negative 2, that's a negative 4. If I bring it over, it's going to become a plus 4. So I have negative m minus n equals to negative 12 plus 4, so that's going to be negative m. Here is one equation. Now I'm going to use my second given information, so x minus 2 is a factor. That means f at 2 equals 0. So that's going to be 2 times 2 cubed minus m times 2 squared plus n times 2 minus 2 equals 0. So that's going to give me 8 times 2. So that's 16 minus 4m plus 2n minus 2 equals 0. 16 minus 2, that's 14. Bring it over. So you have negative 4m plus 2n equals negative 14. And that's my second equation. So you see now I have two equations and two unknowns. Going back to grade 10, I can either use elimination or I can use substitution to find m and n. So let's see. I can use either or. Let's use elimination. So negative m minus n equals negative 8. And I have negative 4m minus or plus 2n equals negative 14. In order to use elimination, I need to have the same coefficient, but with different signs. So easy part is I can multiply this whole thing by 2, because then I can eliminate the n. So that's going to be negative 2m minus 2n equals negative 16. And then my second equation is going to stay the same. Now I can add both of these equations. So negative 2m minus 4m, that's negative 6m. And then this and this, they're going to cancel each other. That's why it's called elimination. Negative 16 plus negative 14, that's going to be negative 30. And then now I can divide by negative 6, so m equals 5. Ooh, I found what m is. If I place m in one of these equations, so what I have here is negative 5 minus n equals negative 8. So negative n equals to negative 8 plus 5, that's negative 3. N equals 3. And that is my final answer. So therefore, I have m equals 5 and n equals 3 and done. So I've used the given information of using the remainder theorem or the factor theorem to solve for m and n. And remember, we have to use elimination or substitution from what we've learned in grade 9 and 10.